Hey everybody, so in this video I'm going to show you one of the most common privilege escalation attacks that are performed during an internal pen test engagement, and that is lowering the authentication method of a domain controller to be net NTLMv1 with ESS disabled, and then using that to crack it manually in Hashcat and convert that to NTLM. So first I'll describe what the attack is, and then we'll do a walkthrough of it, and then we'll finish with how to remediate the attack. So to kind of give a high-level overview of how authentication happens between a client and a server, whenever a client wants to access a service that's on that server, we'll go through this diagram. So we have a client on the left that's first going to make a connection to the server and say, hey, these are the ways that I can authenticate to you. So it could be like, hey, I can authenticate with NTLM version 1, or I can authenticate with NTLM version 2. So once the server receives that, it'll say, hey, let's authenticate with NTLM version 1. And it's not always version 1, it could be version 2, it just depends on the server. So in this example, we'll say, hey, let's negotiate with NTLM version 1, and it'll send a what's called a challenge message to the client. And the challenge message is used to establish the identity of the client. So once the client receives that, and it understands that it has to authenticate with NTLMv1, it sends back an authentication message which contains the challenge message and the net NTLMv1 hash of the client's password. So what we're going to do in the attack is that the server is actually going to be the Kali machine, our attacker controlled machine, and the client is going to be the domain controller. And what we're going to do is that once the domain controller makes a connection to our server and tries to authenticate, and the domain controller says, hey, I can authenticate with NTLM version 1 or NTLM version 2, we're going to say, hey, let's pick the lower option, NTLM version 1, which is less secure. And we're going to send that to the domain controller, say, hey, let's authenticate with NTLM version 1, and send a challenge message. And then the domain controller is going to send back their NTLM version 1 hash to our Kali machine, and we're going to capture that with responder, and then convert that to NTLM, and then use pass the hash. So on this initial step where the client is telling the server how it's able to authenticate, whether that be NTLMv1 or NTLMv2. The difference between these two is where the vulnerability really exists. So NTLMv1 is an outdated authentication method, and NTLMv2, as you might imagine, is the later, more secure method. And this blog post by LmComparabilityLevel really does a really good job of detailing the differences between them two, and they also have some more posts related to NTLMv1 downgrade attacks, which I found very useful. And to kind of give a brief description of the differences, NTLMv1 uses DES encryption, and the way that it encrypts the NT hash is that it breaks the NT hash into 3 7-byte DES keys. And because of that, each of those DES keys can be cracked and eventually obtain the NTLM hash of the client. Whereas NTLMv2, it doesn't use DES algorithm, it leverages HMAC MD5 algorithm to compute the challenge response. So this makes it a lot more secure and not able to crack in a realistic time frame, whereas NTLMv1, we'll see that we're able to crack it within a couple of days, or using rainbow tables can crack it pretty instantly. And along with this net NTLMv1 and v2 authentication, they could even add a flag to each of those, which is the NTLM SSP negotiate extended session security flag. And pretty much what this flag does is it adds another encryption to each of the versions. And as you see, once we go into the lab, you'll see how it kind of changes the hash a bit and makes it a bit more difficult to crack. So this can be attached to v1. So what we're going to do with the downgrade attack is we're going to get the NTLMv1 and then request that this flag is not set. So even if the client's able to add this flag, we're going to request that it does not add that flag. So that kind of goes back to this step where our Kali or attacker machine is going to see that they can enable that flag, but we're going to say, hey, just NTLMv1 and don't add that SSP flag, or it's also called that ESSP for extended session security. So now we kind of know how authentication happens between a client and a server and the different kinds of authentications that can occur. How does that get set, or where is it determined, or where is it configured on the client? And that's going to be under the network security LAN manager authentication level on the local group policy on the computer. And as it mentions here, and I'll link this below as well, this policy determines which challenge or response authentication protocol is used for network logons. And authentication includes LM, NTLM, and NTLMv2 variants. And also gives some actual examples on how this authentication is used. So user when joining a domain, authenticate between Active Directory forest, and authenticate based on earlier versions of the Windows operating system. And this is the main reason why I see this in environments, is because the domain controllers have to have a kind of old way of authenticating to older machines, so they're not able to be set to only allow NTLMv2 authentication, because they might have an older machine that doesn't support that NTLMv2 hash. And whenever we go into the recommendations, I'll kind of talk about that, but pretty much the recommendation for that is to upgrade systems to allow NTLMv2, and then upgrade the domain controller to just NTLMv2. But that's getting a little bit ahead of ourselves. So to stay on track with what this configuration does is it does have these possible values. And this table down here does a really good job of describing what each of those settings mean. And whenever we check in the registry, we can see these different values, and we'll know what it corresponds to whenever we look at the client in a little bit. So these are the 6 different settings that it can be set to. The first one is going to be use LM and NTLM, and never use NTLMv2 authentication. And then we have use LM and NTLM, and use v2 if the server supports it. And then client devices use NTLMv1 and then v2 whenever the server supports it. And then only using NTLMv2, NTLMv2 and refusing to use LM, NTLMv2 and refusing to use LM and NTLM. And down here it shows where in the group policy that it can be configured, and then where in the registry that it can be set. And down below it even has the vulnerability and then the countermeasure, which we'll go into whenever we go into the remediation, is setting that to be NTLMv2 responses only. So let's go look at the domain controller and see exactly where this is set, and then after that we'll go into exploiting it on the Kali machine. Alright, so we're on our domain controller right now, and we'll go to the group policy, so just gp edit, and it'll bring up right here, it'll bring up the group policy. And to go look at it, we go, since it's going to be a computer policy, go to computer configuration, then Windows settings, security settings, local policies, and security options. And then if we scroll down, since it's going to be network security, scroll down to the network security, and right over here is going to be the LAN Manager authentication level. And if we double click it, we can see what it's set to. So right now it's set to send LM and NTLM, and then only use NTLMv2 when set security is negotiated. And so right here you can see the different options that you can set it to. So we'll leave it right here since we're going to be exploiting this. And then after that we could go look at the registry to see where or how the registry value looks whenever it's set. Alright, so we have the registry right here, and this is the path, so it's going to be on the local machine, and then under system, current control set, control, LSA. And then over here is going to be the LmComparabilityLevel, and you can see that it's set to 1. And if we look over at the document over here, and we look at the little table up here, we can see that it's set to 1, which is that send LM and NTLM, and then only use v2 whenever it's specifically requested. Alright, so now we can go to our Kali box to perform the attack and do the fun stuff. So like I mentioned in the diagram over here, on this second step right here, where the Kali or the server is sending back the challenge message, to do that we're going to use responder, and responder we're going to set the challenge message to be custom, so it's not going to be random. And if we go look at our Kali box right here, and we look at the configurations of responder, which is going to be etc /responder/responder config, and we scroll up to challenge. So right now it's set to random, so it'll randomly send the challenge to the client that's trying to authenticate to it. But what we'll do instead is we'll configure it to be a set value, and that way it'll be a little bit easier to understand whenever we perform the attack and receive the authentication back from them. And one of the ways that we can crack the NTLM hash whenever we receive, or the NTLMv1 hash whenever we receive it, is manually through Hashcat. And there's also some third-party tools as well. However, in a professional environment, you can't use third-party tools as far as like giving it hashes, because that's confidential data, considered confidential data from the client, and we're not allowed to place it on third parties, even if it's a hash and they don't know, what the client, who the client is or anything like that. Just for safety measures, we don't do those kind of things. But one of the popular third-party applications or sites that does that is crack.sh, which has actually not been providing the service for a while. But when using that service, they ask that you set this challenge to the specific value of 1122 all the way to 8, like this. But again, this can be set to anything. You can set this all to all 1s or all 8s or whatever you want. You'll see in a bit how this challenge comes into play, but just for demonstration purpose, we'll just set it to the popular method of 11 all the way to 88, and then just save the file. And now whenever we run responder, and I'm going to do the -v just because if you run responder as is and you get the hash of the same account twice, it won't display it, and -v will always display the hash that you receive. And responder is a very common tool to use on pen test, and I won't go into too much detail on how to use responder or all the stuff that it can do, but in this case, one of the things that we're using is that it sets up different servers. So it sets up like SMB server, FTP server, and so forth, and the one that we're going to be really using is this SMB server. So I set it to on, and again, what we're using responder in this scenario is not to poison anything, but to capture that authentication. So you could also use like in-packet SMB server, but what I like about responder is it has really easy options on downgrading the attack. We'll run it as is, and then we'll use a coercion tool. So for this attack, you do need low-level domain credentials or any domain credentials. And also, without diving too deep into this tool either, DFSCoerce is a coercion tool that abuses one of the protocols that's installed on servers that have network or file shares on them, and it pretty much just tricks the target to authenticate to your attacker target. So you provide it credentials, you give it the name of your machine, and then you give it the name of a domain controller. You press enter, it was successful, and then it tries to authenticate the domain controller onto this SMB share, which is your machine, and this is just a fake share, which is why it gets the access denied. But in responder, you can see that we get the hash. NTLM, it says NTLMv1 hash with SSP flag turned on, and here is the domain controller, which in this case is Mount Doom, and here's the domain Middle Earth, the IP of the host, and here is the hash. Now right here you can see that this looks familiar because this is the challenge that we set in that responder config. And like I mentioned, you can set it to anything, so whatever you set it to would be the value that gets output at the end. And right here is going to be the NTLMv hash, that's the encryption of the NTLM of the machine. And on this first section you can see that there's a bunch of zeros. This is pretty much what the SSP does. You'll see once we turn it off how different it is, but because of these zeros it makes it a bit harder to crack. So this time we're going to run it again, but we're going to disable EES, and if we look at the help of responder, you can see that the flag disable EES, which is default false, forces an ESS downgrade. This -LM is another one that you can try. It forces LM hashing downgrade. if the client's configured to allow that. It's also set to false by default, but in this case we'll just be using the disable EES, but feel free to try that one as well on a real engagement. We'll do the disable EES and then -V to just keep capturing the hashes regardless of if it's been captured before, and we have that running. And then now we'll run the coercion again. And then now whenever we look at our hash, we still have that challenge, of course, that's set for 11888. But if we look at this first section right here, you can see that it's not all zeros like how it was up here. This is going to be a lot easier to crack. So just copy this whole thing right here, and then we're going to be cracking it with Hashcat. So I first learned about cracking it with Hashcat on this Hashcat forum by EvilMog, and he created this really cool tool that we'll be using. I'll also link this down below, but he goes through on how he cracked the hash. And if we go look at the tool over here, it gives you instructions on how to use the tool, how to use it without SSP, and then how to use it against NTLMv1 with SSP. So in our case, we're able to downgrade it to without SSP. And if we go back to our Kali box, I have the tool installed over here, and we'll be copying this one like I mentioned earlier, this text right here from the name all the way down to the end of the response. And we'll be using the NTLMv1.py tool. And here's the syntax to use it. So it's just Python NTLMv1.py --NTLMv1, and then just copy or just paste that copied text from the responder output. You press enter, and it pretty much tells you exactly what you need to do. So there's the domain name, and then the username, the challenge that we had set, which is a /string, the LM response, and then the int response. And here's the different keys that we'll be cracking. So for these first two keys, we're going to be using Hashcat. In this last one, we could actually calculate with just this tool right here. It's super fast. So the main thing are cracking these two keys, and you could either put these in one file as it demonstrates and then crack them, or if you want to be a little bit faster, you could put these each in a separate file and then use two password crackers, and it'll crack twice as fast. But on average, if you do it that way, it takes max of about 3 days. If you put it into one file and then try to crack both of them on one password cracker, it takes about 3 to 5 days in the cases that I've seen. But the good thing is that they'll always crack because it's doing a brute force attack, which we'll show once we do the Hashcat command. So it's not running it against the dictionary or anything like that. It's doing an actual brute force attack, which guarantees that it will be cracked or converted. The only thing, the only issue that might occur is that the computer accounts, they by default change your password every 30 days. So if by chance you're cracking it and then the domain controller changes its password, once you get that NTLM hash, it won't work because the password changed on the domain controller, and you'll have to rerun this and then crack it. So because of those, you might come across different errors if you're trying to use the NTLM hash to authenticate and you find out that the computer changes password. So first let's do the method of putting it into different files. So we'll do #1 for this one, and then for this one we'll do #2. So to kind of break down this command right here, we have quite a bit going on. So for Hashcat, you set the module or the type of hash that you're trying to crack. So in this case, it's going to be -m followed by 14,000. So if we go to the Hashcat help and we look at -m, which is going to be the hash type, and we go down to the 14,000, or better yet, we could just grab that out. 14,000. So this is going to be des, and then the next one is going to be -a with a value of 3. So we look at the help, and that's going to be the attack mode. So -a and 3 is going to be a brute force attack, like I mentioned. So it's not going to be against the word list. It's going to be an actual brute force attack. And this -1 is to use a custom set of characters, and in this case we'll be using the des char set. And if you don't know where that is on your computer, which it should be installed if you have Hashcat on your Kali machine, you could just do locate and then the file. So here's the location of that we'll be using instead of this location. And then you pass it the file that contains the hashes. And then you end it with these $1s, and this is needed because it's a brute force attack, so it needs to find out how many digits the end string needs to have. So in this case it needs 8 digits, so there's $1 8 times. And the $1 is because right here we did a -1 and then we passed it a custom set of characters. So if this was like -2, then this number would be 2, but because it's a 1, this is a 1. So now we're ready to run Hashcat against each of those files, and like I mentioned, this will depend, this path right here will depend on where it's located on your machine. So on my machine it's located right here, and you would change it to whatever it's on your machine. Alright, now we're ready to run Hashcat, and the only thing I'll do is I'll put into an output file of cracked.out. So we'll have that running, and with S you can check the status, and you can see that these are the brute force attempts that it's currently attempting. So just keep pressing S if you need to, and they'll show you the status about how long it'll take. This is on my personal computer, which is a pretty weak VM, that's why it says so long. But in an actual password cracker, it estimates it being in about 3 days max. So here we would go to our second cracker, and I'll just do it out of cracked.out as well, and then we'll have this running. So we'll have these two different crackers running each a file, and like I mentioned, it'll make it go a lot faster than putting them into the same file and then trying to crack them.
2 days later.
So it finished cracking. So if we look at the files and we see that cracked is there, we output that out, and this was the des key that we cracked, or that we put in the hash file, and here's the NTLM portion of that key. And like I mentioned at the very beginning, it divides it into 3, and then it does des encryption on those. So we have 2 of them. The last thing we need to do is get the last 4 digits, and if we look at that output from that NTLMv1.py tool, it has to calculate the final 4 characters of the NT hash, just perform this, and this bin right here should be located on your Kali box. You can do the locate to find that as well, and here's the path of it. So if we copy this and then copy that, and then these strings right there, it calculates the last 4 digits. So now we can generate our hash, and so it's going to be, this part is going to be the first part, and here's going to be the second part, and then over here is going to be the last part. So this right here is going to be our NTLM hash of the machine account. So now that we have the NTLM hash, we can perform a pass-a-hash attack using crackmap_exec. So let's do crackmap_exec, SMB protocol, the IP address of the machine that we coerced, or the domain controller, and the name of the domain controller, which has a $sign at the end because it's a machine account, -H for providing a hash, and then the hash that we generated over here. And then I just do --shares, and we get the authentication that it was successful. And the good thing about this is that once you have the machine account, you can perform a secrets dump and obtain NTLM hashes of other accounts. So now we're able to authenticate as the domain controller or computer account. We'll use impact secrets dump and then pass it to the domain, the name of the machine account, make sure to put the $sign at the end, and then the machine that we're going to authenticate, which is in this case going to be itself. Give it -hashes, the colon, and then the hash that we got from Hashcat, -debug, that's optional, and just provides output if you have any errors, so provide more verbose output on the issue. And then -justdc user, if you want to grab just one user. In this case, it's going to be a domain admin. In a real environment, that's what you would do. You wouldn't just dump all the NTLM hashes, because that's a pretty bad security risk, because it creates the file on the domain controller, and it's also very noisy. And then just the DCIP to help authenticate it, and you just press enter, and it grabs the NTLM hash of the domain admin right over here. And so now we can use this with crack map exec -h, give it the hash, and press enter, and then it shows authenticated and pwned in this case because you have access to the admin share. So that's pretty much how to go through the whole attack of downgrading to NTLMv1 with EAS disabled. So the recommendation for fixing this is to hire the authentication that's allowed from your domain controller to be just NTLMv2 as the lowest. One of the issues that might arise from this is that there might be machines in your environment that aren't able to authenticate with NTLMv2. So if they're an older machine, then they'll have authentication issues in the domain if the domain controller gets set to NTLMv2 only. So one of the recommendations to do is to first audit on the domain controller, and I'll link this article below on how to audit, but you're pretty much looking for the event code of 4624, and it provides the machines in the domains that's performing that request or authentication, and the version that it's authenticating as. So you would go through here, you would look at these event logs, see who's authenticating, if they're allowed to authenticate to NTLMv2, and if not, if it's because they're an older system, then you need to upgrade those system and then perform the audit again. So once you know that the machines in your environment are all able to authenticate or aren't authenticating at NTLMv1, then you can make this change on the domain controller. So if we go into the group policies of the domain controller with GP edit. So in the group policy editor, you just go down to Windows settings, security settings, and local policies, and security options, and then go back down to the network security, LAN Manager authentication. And in the background, I'll have reg edit to see the registry change its value. So in the back, I'll have the same path that we mentioned earlier: local machine, system, current control set, control LSA, and this LmComparabilityLevel is going to be what's changing. So over here, we'll double click, and then we'll change it to send NTLMv2 response only. Click apply, and once you click apply, it'll ask you to confirm, and then you select yes, because it's actually asking you to confirm since, like I mentioned, computers that don't allow NTLMv2 authentication will have authentication errors in your domain. So that's where this confirm prompt comes up. And once we look back, so before it was set value of 1, and if we look back now, it's the set value of 3. And if we were to go to our Kali machine and then try to perform that same attack where we do the downgrade, so we have responder running, asking it to disable EES or ESS, and then we'll perform the coercion attack again. And you can see that now it's NTLMv2 hash with SSP enabled, and that's even with us requesting that it doesn't enable the ESSP flag. And you see that the string's a lot longer, and even though the challenge response is set, this long string won't allow you to crack it within a realistic time frame, especially with computer accounts where their passwords are very long and a random set of characters pretty much, so it's not an easily guessable password either. So that pretty much covers how to remediate the attack as well. Again, make sure to audit it before you set that flag so you don't cause any errors in the environment with old machines trying to authenticate. And besides cracking the hash with the NTLMv1, what you could also do is relay it to other machines, which I'll create another video about, so you don't have to go through the process of waiting for the hash to crack. You could relay it and then take control of other computers in the domain.